Okay, hello again. This is a very simple relay design which I made. I at first I made this version which is larger than this one. So you can see basically what it is it's an angle aluminum piece with two 3-inch bolts, a 1-inch a a bolt with a 1-inch flat end, as well as another threaded end, as well as another smaller bolt. So basically what I did is I wrapped some 30 gauge copper wire around the flat end of this bolt, and it creates an electromagnet, and it bends this piece of plastic which actually came off of a DVD case. I cut off the piece of plastic, and so the plastic is an insulator, and this is a conductor, and this is a conductor. So whenever the relay switches, there's a little gap here, and that gap closes. So so I designed that, but this does require a lot of force to close this, and it uses extra materials. So I redesigned it just to have one end. It works in much the same way, but it uses less materials, less plastic. And instead of using an angle piece of aluminum, I simplified it to just a little piece of a big aluminum bar, which I just got at the hardware store. This isn't necessary, but the entire purpose of this is just to conduct electricity. Actually, if you don't even need it to conduct electricity, but you do want it to conduct electricity, so you can connect it from these 2 points. So it would go down and up, and then here on this little end. If you wanted to, you could just connect this up to a piece of plastic, and it would have to be a thicker piece of plastic than this piece, but you could connect them to a piece of plastic and you could have electricity flow from here to here. But I use the piece of aluminum, so it goes like this, and you can connect it from these 2 ends. Even though this one has its ends here and here. So I made a few more of these. Actually, what I did is I had tape here to keep the wire in place. And actually, if you're wondering about how many times you have to wind this, because you want it to have higher resistance and more winds to have a stronger electromagnet and less heat generated, this is wrapped around 7 times. So 1, 2, 3, 4, 5, 6, 7, up, down. Each one of them is actually, so I have 4 right now, and there's still this extra hole to connect it to stuff. I was thinking about making something actually out of these. For example, a relay computer, which would be huge. I probably would not get very far, but I would like to make just some simple logic gates, maybe even an adder subtractor circuit with this. Maybe I could make it smaller, but I don't know how this would work for. And you can modify these relays for different logic gates, such as right now it just turns on and off. But if you wanted to have this, for example, be a NOT gate, where where whenever this would happen, it would turn off. You could get another piece of plastic, put it here, and put another bolt there. Or if you want an AND gate where both of them have to be on for it to turn on, you could do something where they would be connected like this. And you would go in between. You would measure in between this pole and this pole. But of course you wouldn't want to mount them like this because then it would bend. But that's the point. So let's power them up and see one working, just to prove that they actually do work. So we have it set on resistance. 0L of course means no connection. We're at cooking elevator clips to the leads. And this into focus, so 0L, but when I connect the clips together, so that would mean that it's working. So for this relay, we're going to take advantage of connecting it. Connecting it here. And connecting it here. So like this. So it's a 0L, but if you push it down, it's a 0. So let's turn on the power supply. We are actually going to power this up with 3.3 volts of electricity. You want to use lower voltages to minimize heat dissipation, which is going to get pretty high pretty fast if you have to use a lot of these to make logic gates. So turning on the power supply, you can hear it click a little bit. So 0, and turn it off, disconnected. Of course you can mount it up and down. To show you closer about what it actually does. Of course you can raise and lower this on the bolt to adjust it. Let's try this one. This is not connected to the multimeter. I proved that. But as you can see, there's a bit more space in between here, which doesn't really matter. So you can still connect it. So the issue we're having is with the magnet wire. So the magnet wire will connect on one part. Okay, so maybe this one is a bit too high. But it's okay because you can adjust it. And now it's too low. So you want to... If you use higher voltages, you could get it to work like that, but I want to avoid that. Here we go. So you can see it's still higher up than the other one because it has a higher click. You can hear it. And you can see it bounce up and down. So let's Let's make it go a lot. So you could also use this for a telegraph if you modified it a little bit. The part that goes up and down and up and down. And the switch part too. Improvements would be clearing off more space in the magnet wire. So we can just play with that all day. But let's talk about some of the improvements and uses for this. Improvements could be making it smaller so it would be less expensive, as well as less power consuming. Also, if you make it smaller, you can fit more into a single space, which again for a computer would be important. But this is actually why you would want to do this instead of buying relays. This is actually pretty inexpensive to do. These bolts are pretty cheap. A relay of this size could be like $6 or more. So you get a piece of metal here, some metals here. These parts are not usually sold individually, but if you want a lot of relays, this can be pretty cheap. For a roll of magnet wire, such as the roll that made all of these relays, everything here, it'd be like $8 for 30 gauge magnet wire. So if you wanted to do this, this would be a good thing to do. Just keep in mind, if you're designing this for a specific purpose, the input voltage you're using, and for the switching voltage, I wouldn't really recommend connecting this to a wall outlet, just because everything is exposed. But for 12 volts and just switching stuff for sending data, this would be a good option to use. So that's it for this project, and hopefully we can find something to do with these. If not, I'll just share them out there so you can see what these might be used for.